Hi friends, welcome to those of you who have just found this channel. This channel is one of the channels that provides educational materials in the form of animations. This is the question that we will discuss in this series. The question is quite long. You can read this question for 10 seconds. Do you understand this question correctly? Let's watch the following short animation. There are two stacked blocks connected by a rope. The rope connecting the two blocks is passed to a pulley. Thus, when the rope moves, the movement of the rope can rotate the pulley. Then the block at the bottom is pulled to the right by an external force. Of course, the block pulls the rope behind it. The pull of the rope then pulls the block above the block. So the two blocks move in opposite directions. If the lower block shifts to the right, the upper block will move to the left. Now we are asked to draw the force lines acting on this system. Of course, the equation of motion of the block. And the last is the magnitude of the external force needed for the system to move at a constant speed. Now we understand. Let's start answering the first part of this question. Before going further, we will identify some important quantities. Let's say the mass of the upper block is m1. The mass of the lower block is m2. The surface of the block and the floor are not slippery. There is a coefficient of static friction. The magnitude of the coefficient of static friction between the surface of the block and the floor, and between the surface of the block and the block is the same, namely mu. For the pulley, there is no information in the question. We can ignore the movement of the pulley. An object moves or does not move because it is influenced by the force acting on the object. For the upper block, this block gets a gravitational force of m1g downwards. This block does not penetrate the surface of the block below it. Of course, block 1 gets a normal force n1 upwards. This block is connected to a rope. There is a rope tension force. The direction is in line with the rope. Because both surfaces of the block are rough, the upper block will get a static friction force to the right, Fk1. It seems that this is the only force diagram for block 1. For the lower block, we do not know the magnitude of the external force. The force is F. Block 2 is also connected to the rope. There is also a rope tension force. For the surface of the block and the surface of the floor, there is a friction force Fk2 to the left. The magnitude of the gravitational force acting on the lower block is m2g. Is this the only force acting on block 2? Look again more carefully. The force is an external action. Where there is action, there is reaction. This is true, isn't it? If at the top a force Fk1 works to the right, of course a force of the same magnitude and opposite direction will also work on block 2. This means that block 2 also works force Fk1, but the direction is opposite to the direction of Fk1 on block 1. You can understand this if you have time to watch the motion dynamics course on this channel. Furthermore, the upper block presses on the lower block. Thus, the molecules in the lower block push the upper block with a force known as the normal force, N1. This force N1 arises due to the pressure from the upper block. This means that the lower block also has a force N1, but its direction is opposite to the force N1 acting on block M1. One more thing, the lower block presses on the floor surface. Of course, the floor surface will provide a reaction force that is directed upwards. This force is none other than the normal force N2, which is directed upwards. So on the lower block there are two normal forces working at once. This is the force diagram in this system. Now we will answer the second part. Newton's laws work for every object. Different objects apply different Newton's laws. For the first block, we will write the equation in two directions, the vertical direction and the horizontal direction. For the vertical direction, the block does not move up or down. The resultant force in this direction is 0, and 1 minus m1g is equal to 0. For the horizontal direction, the block moves to the left, so the direction to the left is positive. In motion analysis, the direction that is in the same direction as the direction of motion has a positive sign. T minus Fk1 is equal to m1a. Since the question has mentioned that this system is moving at a constant speed, the acceleration value is 0. For block 2, we will also analyze the resultant force in two directions. For the vertical direction, there are 3 units of force. N2 minus N1 minus M2g is equal to 0. For the horizontal direction, block 2 moves to the right. F minus Fk1 minus Fk2 minus T is equal to 0. The resultant force is 0, because this system is moving at a constant speed. These are the 4 equations of motion for objects M1 and M2. Knowing these 4 equations, we can calculate the magnitude of the external force. We start from the equation that looks the simplest. That's right, from equation 1, N1 is equal to M1g. Next is this equation. T is equal to Fk1. The friction force is mu multiplied by the normal force. T is equal to mu m1g. Now is this equation. N2 is equal to N1 plus M2g. We already know the value of N1. N2 is equal to M1 plus M2 multiplied by g. Next is this equation. F is equal to Fk1 plus Fk2 plus T. All of these values are also known. F is equal to mu times 3m1 plus m2, g. This is the external force required to pull the block so that the system moves at constant velocity. Hope this helps. And don't forget to watch the next video.